Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Vector Databases. The AI's superpowered long-term memory. Imagine you're talking to a super smart friend, but they forget everything you said an hour ago. That's often how powerful AI models like ChatGPT work. They're brilliant, but their short-term memory, called the context window, is limited. For AI to be truly smart and helpful, especially with large amounts of information, it needs a super-powered long-term memory. Today, we're diving into vector databases, the secret sauce that gives AI this incredible recall, making it smarter and more capable. As developers, we're used to databases like SQL, PostgreSQL, MySQL, or NoSQL, MongoDB. They're fantastic for storing structured data, names, dates, numbers, and categories. You ask, give me all users named John, and it's fast and precise. But what if you want to ask, show me ideas similar to John's hobbies, or find articles that discuss a similar concept to this paragraph? Traditional databases struggle here because they look for exact matches or specific patterns, not conceptual closeness or meaning. AI needs to understand meaning. Don't let the math Y name scare you. At its core, a vector is just a list of numbers that mathematically represents something. It could be a single word, an entire paragraph, an image, or even a piece of audio. Think of it like a unique digital fingerprint or a set of coordinates on a super complex map. The magic is this: if two ideas are conceptually similar, their fingerprints, vectors, will be numerically very close to each other in this multidimensional space. This is how AI starts to understand meaning mathematically. So, how do we get these magical number lists? Vectors. From plain text, images, or audio? We use special AI models called embedding models. As a developer, you'll feed your data, e.g., a sentence like, "the quick brown fox," into an embedding model, and it will output a vector, e.g., 0.12 minus 0.45, 0.88. It's like having an AI translator that turns human understandable content into the mathematical language of vectors, making it machine readable for understanding similarity. These models are the bridge between human language and AI's numerical understanding. Okay, now we have millions, billions, or even trillions of these idea fingerprints. Vectors. How do we find the ones that are most similar to a new idea? Quickly and efficiently? If you have millions of unique numerical fingerprints, scanning through every single one to find the closest match would be incredibly slow and resource-intensive, especially as your data grows. This is where traditional databases, designed for exact matches, completely fail. They aren't built for nearest neighbor searches on high-dimensional data at scale. This is where vector databases shine. They are specially designed databases built from the ground up to store, index, and efficiently search through these high-dimensional vectors. Instead of searching for exact keyword matches, they perform similarity searches, finding the vectors that are numerically closest to your query vector. Imagine a librarian who doesn't just know exact book titles, but truly understands the asterisk themes and concepts of every book and can instantly recommend others with similar ideas, even if they use different words. That's precisely what a vector database does for AI's memory. As a developer, mastering vector databases opens up a world of possibilities for building truly intelligent applications. Less than all greater than less than li greater than less than b greater than retrieval augmented generation. RAG. Less than b greater than powering chatbots and LLMs. Like ChatGPT, that can access and remember vast amounts of specific, up-to-date, or proprietary information. Your AI won't just hallucinate. It'll look up facts from your knowledge base. Less than, li greater than, less than, li greater than, less than, b greater than semantic search. Less than, b greater than building search engines that understand the asterisk meaning of your query. Not just keywords. Search for things to do with kids on a rainy day, and get relevant activities. Not just pages with those exact words. Less than, li greater than, less than, li greater than, less than, b greater than recommendation systems. Less than, b greater than suggesting products, movies, or articles that are conceptually similar to what a user likes, leading to more relevant and personalized experiences. Less than, li greater than, less than, li greater than, less than, b greater than anomaly detection. Less than, b greater than finding unusual patterns or outliers in data by looking for vectors that are far away from the typical cluster. Less than, li greater than, less than, ul greater than. These tools are becoming an essential part of the modern developer's toolkit for building next-generation AI applications. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.